Great seeing you here. My name is Luc de Kuster, founder of the Kuster Academy, and in this video I will concentrate on the effect of bottlenecks or constraints, like Goldratt called them, on throughput and cost. It's very important to see what happens because it has a very big consequence when you really understand what is happening here. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube can inform you about it. So let's have a look and see what we have when we look at cost calculations in a classical way. Now, classical operations environments are in fact where the COO, the Chief Operating Officer, or the Operating Director or Manager were pushed to produce at minimal cost, considering each process step individually, which leads to maximize the output. So we look at every process step, we see what's the capacity, and we try to complete as many as possible items because then the cost per item goes down. That's the reasoning behind this. Now, what the cost per item is, so basically the more they produce in each step, the lower the cost. And basically, when we consider the theory of constraints and the principles of the constraints, this is not really the way it should be. Another element that happened is that they would never stop production, or interruptions were only allowed when a machine broke down. Now, when a machine breaks down because it is not maintained properly, it will create or can create more damage than anticipated. And what happens is that the repair time takes longer, and when you have this on a bottleneck, you are really in the problems because the bottleneck will in fact stop all the output of your production. Now, the element what then happened is that the people were driven to make more parts, make more units, because they wanted to compensate for the lost time. And that again is an element where you create more items which are not according to quality levels. Now, the estimated cost of the interruption was calculated in that moment using the cost of the items that were not produced. So they were looking at the step, they were seeing what was the time lost or the amount of elements lost, and that was the calculation of the loss. Now, when we look at a bottleneck and the breakdown, we look at case 1. Let's have a look at case 1. Case 1, we have a breakdown of process 2 with a capacity of 5,000 units per cycle. We get an input of 1,000 units. We have there, when this item breaks down per time unit, you have an accumulation of 1,000 items, 2,000, 3,000, and so on. Now, what happens here when this element is producing at maximum capacity, or in this case only at a capacity of 1,000, because we have no more items coming in. We are only having 1,000 items per time unit, so we're producing below the capacity. But that amount of work in progress that's waiting here will be sent, or once this step is producing again, it will in fact be going through the process very quickly. And we know that in front of the bottleneck, the red item here, 300 units per 300 units per time, we see that we have a work in progress there. So when the breakdown is limited, we can use the WIP waiting before this step to continue production. So as long as the interruption is not too long, we still have enough items to continue production, and our output is still at 300 units. Now, the fact here, we have process 3 still working at the 300 units. We don't have a real effect on the process, on the throughput like this. But of course, if the process step number 2 is down for a very long time, at that moment, the effect will be felt also in the bottleneck. And at that moment, we have a different problem. But let's say that the interruption doesn't take too long. We don't really have a problem here. Now, let's have a look at case 2. And what we have now, the process 3, the bottleneck, breaks down. We have a capacity of 300 units per cycle. Now, what happens here is the process stops. there are no more items that can be processed by process 4. So it has immediately an effect on the throughput. The element what we have here is that even all the elements that are waiting in front of step 3, we can never produce more than 300 units. And the longer this step is down, the more items are not completed. We block the entire production for the time of the interruption of the bottleneck. And the interruption can be a problem. It can be due to maintenance. It can be due to changeovers. So we have to really optimize whatever we do with this bottleneck. We also have to see that the items that come to the input of the bottleneck are of good quality, because all work that is done in bad quality or bad quality items will also have an effect on the output. And it's very important that this process works perfectly. When it works perfectly, it means that all the items comply with the quality standards. If they don't comply, there is a big problem. So basically, you have to see how it works, and you can see how the things are working in all these elements. We spoke about the losses. We looked classically at the cost of the production losses related to the step that was broken. And this is not correct, because we have to consider the effects on the total production. Once the bottleneck is broken down, it stops the entire output, the output of the production. When process 2 broke down and is repaired in a reasonable time, the whip in front of process 3 can be used to continue the production, and it will have no impact on the final output. However, when process 3 breaks down, the losses cannot be compensated because of the limited capacity of the bottleneck, and the capacity is lost forever. What we want to do is we want to know the cost of the breakdown of the bottleneck. We have to consider basically the entire capacity and divide it by the duration of the interruption. Imagine you have a bottleneck, your production capacity is 300 euro per minute. It means 18,000 euro per hour. Now, I was working with a factory, and the problem that they had was that they had some issues where they could not send out certain items because it was not complete. Of course, you have to have the people, you have to work with them, and you have to deal with the people, and you have to pay them. But when you have a loss of 300 euro per minute, it's a lot of money. I want to be paid 300 euro per minute. Sometimes I saw engineers saying, okay, I will have a look at it tomorrow. So basically all the capacity of that production was lost for 24 hours. Imagine the effect when a bottleneck step is out of production because you cannot recuperate the losses. When we look at throughput and the cost, we look at the production, and once we see this, once we understand what is happening, we look at production in a different way as before. The identification of the constraints is a constant effort of the management, and the decisions have to be adjusted to optimize operations. You have to reduce costs and increase throughput. Throughput in a project is the number of items that are completed, not the work that is waiting to be assembled. We also have to adjust production to consider the effects of the bottleneck. When every step will produce at maximum capacity, we will send raw materials into the production process for an equivalent of 1,000 units per cycle, and we will only produce 300 items finished products. And this has an important effect on the throughput and the cash flow. You're putting money in the system to create work in progress, and that is not the goal. You want to create finished products that you can sell. The large amount of work in progress in the process also leads to quality issues. Quality issues that you detect very late, damages and other negative effects that even accumulate on it. The just-in-time method is basically reducing the work in progress. The work in progress is only limited to the items that are in the Kanbans that are going between the two processes and nothing more. But you have to find out, you have to manage the process, you have to find out where are the bottlenecks, and bottlenecks may change depending on the processes that you are implementing at a certain time. So that was it about the effects of breakdown of a bottleneck or breakdown of a normal process step. Anyway, that was it for this video. Don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and I'm looking forward to seeing you in our next video. Bye bye.